Hello all, David LaFazia of course. I'm going to go through and give you some very basic instruction on charge. And there are three methods of charging. One method is charge by friction, which is actually what we think of when we look at that John Travolta simulation. So John Travolta was rubbing his leg back and forth, and there was this electrical interaction there, and so he built up what we call charge. And by touching something metallic, something that could easily accept those excess electrons, the charge was actually able to jump from Travolta's finger into the metal. So you can charge something through the violent interactions of rubbing. For instance, if you take a balloon and rub it against wool or some certain hairs, then you can actually produce this violent reaction where electrons are actually stripped off of one material and onto the other. And what ends up happening is the one that the electrons were taken from, that ends up as more positive, because originally we're all neutral. So you get electrons taken off, you end up being more positive, and so the receiving end is more negative. And we always consider the electrons, that very free particle, to be what is doing the moving. So we do the same thing in electrical circuits. So we consider the idea that you can take something and rub it against another material, and depending on how they are electrically, they will produce a charge. So you might have one type of material that you throw in, maybe a wool sweater, and then you have, I don't know, a polyester sock, something like that. And as they interact in the dryer, for instance, you build up this static electricity, and you can see that they attract to each other. So charge by friction is kind of a fundamental way of building up charge. And then you can actually do that charge by conduction. So let's say that you have an object that's charged. Let's say that I've built up some charge on this piece of styrofoam, and then I can transfer it to another, either non-conductor or conductor. But if I transfer it to a non-conductor, then the charge pretty much stays stationary there. So you take a balloon, and maybe you contact it with another balloon, and you can give some of that charge over. You can actually allow it to transfer through conduction, through touch. So we have charge by friction, and then we can give charge to other things through charge by conduction. And then there's actually something that involves a distance, and that is charge by induction, the root being you induce a charge. And you've seen this in the simulations, or you will shortly. Basically, you take something that's charged and you bring it towards an uncharged object, and the electrons are very free. So they're able to move about in what we kind of consider an electron cloud, if you will. So if this is a positively charged object, and I bring it next to a neutrally charged object, then the electrons are going to be attracted to it, and technically the positively charged object would be repulsed by it. But let's pretend it's fixed. So I move it closer, the negative portion is somewhat oriented towards the positive charge. And so you get a positive sense and a negative sense. And you saw this with Dr. Patrick Particulate as you were exploring charges. So I'll show you a couple examples of that. This is a little mini Van de Graaff generator. And the Van de Graaff generator uses the idea of charge by friction and charge by conduction in order to build up a charge here on the end. And if I do that, then I can actually give a charge by conduction, to this object. And that object is charged. And as you saw, it went towards the cabinet here, and the cabinet itself is neutrally charged. But in order to have this attractive force, the action, you actually end up with an induced charge. And that means that locally, the electrons were influenced to cause a more positive or negative sense. So with that, we then see the attraction. And once they attract, then all bets are off. The charges have been transferred, and then we have a return to the neutral state as soon as possible. So an example of charge by conduction and then seeing what happens once the charges are near each other is I have a number of little mini pie plates, mini quiches. So I can induce a charge through charge by friction, then charge by conduction. And since they all have the same charge, they're very repulsive to each other. Now, as they're flying through the air, they lose some of that charge because of interactions with the air. And if they come near another object, then they again induce a charge, and then they're attracted to that object. So the last little demonstration is this image of the Mickey Mouse molecule. This is the water molecule. So you have the oxygen and the hydrogens. And you can see that it has a very specific positive side and a very specific negative side here. Hydrogen is positive and the oxygen is negative. And one of the advantages of this is that I can then use that. I can create a little stream of water. And I'll zoom you in. And I can induce a change by actually reorienting the molecule. So I have a little bit of charge built up here. And you can see that the only thing that's causing this to actually move or for the stream to deviate is in fact the charge. So we have the three methods of charging: charge through friction, charging through conduction, and then the very interesting charge through induction. Don't want to waste water. And hopefully you begin to get a sense of how this could occur in nature and maybe some of the applications as well. But ultimately, it relates to large-scale electrical production, depending on how you decide to move those charges.